Hello guys, and welcome to another geography episode. Today we're going to look at the supplementary examination of 2017, and the reason why I want to go over this question paper because this is something that you're going to write very similar to this question paper that we're going to discuss today. So let's continue with this question, and I took some questions out of the question paper that I think is quite important and will definitely help you in your examination. Now the first question referred to as synoptic weather map. Now, a synoptic weather map is basically a map showing us the weather conditions on a daily basis. And there's a couple of things that I want you to pay attention to. Look at the date, that's October, and look at the time, that's 2 o'clock in the afternoon. And another reason why I can tell you that this is summer is because there's a low pressure over the interior. Why a low pressure? Because of warm conditions, air rises. Okay, as you can see in your left bottom corner, we have a mid-latitude cyclone. You can actually see the cold front over there. And also that I know it's summer, you can see that the South Atlantic high has migrated south and is actually blocking out this mid-latitude cyclone. But let's look at the questions that's being asked regarding this synoptic chart. The synoptic weather map data was captured. Now we looked at that. 1400 hours, 2 o'clock in the afternoon. Answer is right there in front of you. Situated over there. Okay. If you look at the next question, the season represented by this synoptic weather map. If you look at the date, it represents the 10th. It's definitely going to be summer. Now, area A on a synoptic weather map is a ridge or a trough. Now, if we quickly look at area A, that's an extended area of low pressure, and that is known as a trough. What is a ridge? It's when the high pressure cell, usually the South Atlantic, isobars are elongated over the west coast of Southern Africa. But A is definitely an extended area of low pressure, namely known as a trough. So a trough is the correct answer over there. The weather system associated with the area at A creates what? Stable or unstable air. Now, unstable is the correct term that we use because why is it unstable? Because of warm conditions, what does the air do? It rises. Usually with a high pressure, we associate stable air because it's sinking air, it's subsidence taking place. But with low pressure, it's unstable air because the air is rising. So we can just write down there, unstable. If we quickly have a look at the wind at weather station B, is it north-northeast or south-southwest? Let's quickly go to weather station B and have a look. And there you can see this weather station B. Remember, there's north, there's east, there's south, and there's west. Now, if you look at the direction of this little arm on the weather station, it will definitely be north-northeast. So north-northeast will be the correct answer. North-northeast. If we look at the wind speed of weather station B, let's quickly have a look at it. Is it 20 or 10 knots? Okay, I just quickly need to get my... If we quickly look at that. Now, if we look at the weather station over there, right over there, that looks like 20 knots for me because if I can redraw that weather station, it looks something similar to this. That's the cloud cover. Direction of the wind goes north-northeast. And exactly the same length, so in temperature it looks like 23. So definitely 20 knots is the wind speed that's being experienced over there. So we can just write down there 20 knots. Now if you look at question 1.1.7, the air pressure at the center of the South Atlantic anticyclone, okay, if you look at an anticyclone, it's a high pressure system, and we looked at it, is it lower or higher than 1032 hectopascal. Let's quickly have a look. The center of it, there's it, the center, there's the reading 1032. So the correct answer will definitely be higher. Very importantly, when we looked at this question, grade 12s, have a look, when you answer questions on the synoptic chart, the answers is usually right in front of you. You just need to be able to go and know where to go and look for the answers. And take your time once you answer the questions regarding synoptic charts. Remember, all the clues is right in front of you. Start looking at your date, looking at your high pressure systems, and the date will tell you if it's going to be winter or is it going to be summer. And look at your weather stations, look at the temperature and especially the cloud cover when you look at your weather station models. It will give you a clear indication what's happening in the next 24 hours. All right, let's quickly go to our next questions. And 1.3, it shows a three-dimensional mid-latitude cyclone in the United States of America. Now that's key. Keep in mind, there's going to be a different circulation of air taking place because this mid-latitude cyclone is in the northern hemisphere. Now what do we know? In the southern hemisphere, a cyclone turns clockwise. But in the northern hemisphere, a tropical cyclone or mid-latitude cyclone moves anti-clockwise. Now I'm just going to fill in a little bit over there. There you can clearly see the cold front. There you can see the warm front at B. Now if you can look at the system, because it's in the northern hemisphere in America, look at the anti-clockwise circulation taking place. Very important over there. Let's quickly go and have a look at the questions that's being asked. Name fronts A and B. Now I've just drawn over them and that's quite easy. A is definitely the cold front and B is the warm front. A and B is the warm front. On what stage of development is this mid-latitude cyclone? Now let's quickly go and have a look, and how can we determine it? I will definitely say it's in the mature stage because this cold front is almost caught up with the warm front, and as you can see there's already cloud formation taking place along the cold front where the warm fronts are being forced up to rise, where it cools, condenses and clouds. So definitely in the mature stage. Give evidence in the diagram to prove that this mid-latitude cyclone occurs in the northern hemisphere. Now I've already shown you this. As you can see it moves in an anti-clockwise circulation. So that's our first piece of evidence. Just want to write down there, anti-clockwise circulation. And they've mentioned that it's a mid-latitude cyclone in the USA. USA stands for United States of America, and the USA be found in the northern hemisphere. Sometimes you can get some clues for your answer in the question itself. Remember that. Now, if you look at that question 1.3.4, excellent question. Give a reason why front B is associated with greater rainfall extent than front A. Now, let's quickly have a look at front A and front B. Now they reckon there's going to be more rainfall at B than A, and you can actually see it with the amount of cloud cover. Do you see the amount of cloud cover over there? And look at the extended area of cloud cover over there at the warm front. Now the reason for that is because if we look at the nimbostratus clouds form at the warm front, and we can mention the nimbostratus clouds, nimbo means rate, are more elongated along the front, okay, and that creates more widespread rainfall. And the gradient, pressure gradient, is more gentler. Is gentle. So it's not cumulonimbus clouds like at the cold front conditions where the air is being forced to rise because of that cold air moving in. It's more gentle, right? It's gentler pressure gradient, so it will have experienced more rainfall than at the cold front where the air is being forced to rise. Now if you look at question 1.3.5, describe the likely weather conditions associated with the cloud type at front A. Now immediately, now keep in mind what I've just explained. The cold front approaches, it forces the warm air to rise. It cool condensing clouds. So cumulonimbus clouds, cumulus nimbus, and that, what's associated with cumulonimbus clouds? Heavy rainfall. Heavy rainfall over a short period of time, definitely thunderstorm activities. Thunderstorm activities because of the strong updrafts being created. Okay, now if I can just quickly, I want to draw to you on the bottom of the page, so just quickly revise a little bit. If we look, that's a surface, let's say for instance that's our cold front, and that's our warm front, that's a cross section through it. As you can see, as the cold front approaches, it moves from west all the way to east. Now as you can see, look at the pressure gradient, it's much steeper. So this air forces to rise, and that's the reason over here we have cumulonimbus clouds. And over here the cold air just slides over, the warm air just slides over the cold air. And that's the reason we have nimbostratus clouds situated over there. Look at that pressure gradient, it's much steeper over there than over there. Okay, if we look at our next question, 1.3.6. Discuss two expected weather changes that could occur when the mid-latitude cyclone reaches the occlusion stage. Now what happens with the occlusion stage, if I can quickly draw it for you, it's when the cold front eventually caught up with the warm front. So it's a mixture of warm and cold fronts and cold air. Now what can happen, we might experience a cold front occlusion or we might experience a warm front occlusion, but let's quickly write down. The air pressure will immediately increase, the temperature will decrease because all the warm air has been uplifted. So the only temperature that's left is the cold temperature from the cold front. Humidity will decrease. And lastly, the wind speeds will also decrease. Also decrease because there's only cold air left on top of the surface. Right, so that answers is basically a mid-latitude cyclone that we find in the northern hemisphere. Pay special attention to the circulation of air. Now keep in mind it's different what happens in the northern hemisphere to the southern hemisphere. Now if we quickly look at 1.5, figure 1.5, It shows the amount of water in a river during dry season and rainy season. Now immediately, if we look at rainy season, it depends. It's also known, what we see over here, as seasonal rainfall. Now, very few places receive rainfall right throughout the year. Some places only receive their rainfall during summer season, and some places only receive their rainfall during winter season. A very good example, I'm going to use South Africa as an example. The Mediterranean climate, the Western Cape, experience most of their rainfall during the winter, and the rest of South Africa experienced most of their rainfall during summer because of warm conditions and the air rises, and it basically led to the creation of cloud formation and may lead to precipitation. Whereas if you look at our Western Cape area, the rain forms over there is because of mid-latitude cyclone conditions and how it affects us only during winter. Now, if you look at the two diagrams, what I can see over here, I see the same river, but during the dry season is completely dried up. And during rainy season, there's surface water. Now, before grade 12, you've learned about two types of rivers, and you were introduced to them in map work: your perennial rivers and non-perennial rivers. And on a map, a dry season, for instance, a non-perennial river would have been a dotted blue line, and a perennial river would have been a solid blue line. In this case, what we're basically witnessing over here is a non-perennial river, because as you can see, it only flows during rainy season. Okay, now the question that follows, question 1.5.1, name the type of river in the photograph. Okay, we quickly need to take a short break. As soon as the break is over, we're going to continue with 1.5.1. See you in a bit.